Okay, so I'm actually very excited to be like a first presenter, and thanks for having me. Thanks for the invitation. I think it's a really nice initiative. That's why I really like it, and I really appreciate that. I have that pleasure to actually start the very first Elixir meeting hosted by the Curiosum company. So I thought that maybe as the first presentation, I will well tell you about some basic stuff about some things that maybe you would find interesting, and also maybe something that will encourage those of you who actually just thinking about switching to Elixir or trying that technology. That actually Elixir and Erlang environment is not only interesting, but it's also very powerful from the tech perspective. So the image that you see now, the picture that you see now, I found it in the very deep part of the internet, but it shows that from time to time in the web, let's say, environment, in the web applications environment, we have to switch down, well, either the application or the server. Obviously, there are many reasons behind that, but one of these is, well, we need to go into, let's say, maintenance mode, or we need to just like release or deploy the new version of the code base. This is not something that we like as engineers, and also this is not something very pleasant for the end users. But this is how it works in a web environment, let's say, word. Let's take a look on a different, let's say, area of technology, on different domain, which is telecommunication. So, well, maybe you've seen from time to time that some website is in the maintenance mode, doesn't work, or there is some delay. But hey, have you ever seen or heard situation like this? Let's say that you have a lovely chat with your grandmother via phone, and then you suddenly hear some voice of the operator saying, well, we have to shut down your call because we're gonna upgrade some software on a telecommunication device. Most probably not. And the question is actually, why the telecommunication area, why is whether the area is much more reliable than web applications. The answer is obviously more complicated, but one of the reasons is the language and the technology that runs on web servers, web machines, and on telecommunication devices. And obviously, I'm talking about Erlang and its younger, well, brother or cousin, Elixir. So in this presentation, I would like to give you some introduction to that environment, and also I want to tell you what are the main features of this environment that makes it very reliable, and how we can use it. I want to encourage you to try a couple of these features to see how it can improve your applications. And yeah, I think it's the best way to try it, just to write a couple of lines of code. I would say that the level of the presentation is rather kind of an introduction to Erlang, to Elixir, and the whole ecosystem. And yeah, my name is Krzysztof Kempiński. I'm in IT for, I think, 16 years. I started actually as a PHP developer, then switched to Ruby on Rails, and spent the most time of the biggest part of my career as a Ruby developer. But I somehow found that Elixir is something that I would like to try. I give it a try. I give it a try, and now actually I have Elixir as my main technology. Also, yeah, as Shimon told, I'm a podcaster for almost 5 years now. Unfortunately, the podcast is only in Polish, so if you speak Polish or you would like to improve your skills in that area, I encourage you to try it. It's called Porozmawiajmy IT. So let's talk about IT. Yeah, and now let's talk about Erlang actually, because I think one of the let's say reasons to understand why this ecosystem is so reliable is to understand how Erlang actually started, and what was the environment and what kind of requirements set for this language. So everything started in the middle of 1980s in the labs of Ericsson, that famous telecommunication company. So that telecommunication, let's say, traffic started to grow heavily, and they started checking existing programming languages to see what kind of language they can pick for their hardware, basically. And after a couple of tries, it turned out that none of the existing languages is sufficient, let's say, for the telecommunication market. So they started actually designing new language, and Joe Armstrong was the guy who actually started that. They mainly started with writing something in Prolog, and they started like inspiring themselves with Prolog. The first implementation was rather slow, not reliable, not that performant. But they show that in the for their partners of Ericsson, actually all of the companies working with Ericsson really liked the language, so they decided to improve the quality, the performance of the language, and the first, let's say, commercial implementation actually was released in 1991. 2 years after that, they decided to create, I would say, the core team, or the team that would develop the language, the environment, and release it regularly. 1996 is a very important milestone, because the OTP Open Telecom platform was created. So the set of the very basic tools that we use now for Erlang and Elixir ecosystem. And after kind of success of the Erlang, the company decided to actually close that language, and none of the partners could use it anymore. It bring the the situation was rather complicated, and not something what Joe Armstrong would like to see for his child. So he decided with a group of other programmers to leave Ericsson. The company actually reflected very quickly, and they decided to release the Erlang as an open source solution very soon. And Joe Armstrong actually turned back to the company also after a couple of years. Currently, one of the biggest companies using Erlang is obviously Ericsson, but also Facebook, T-Mobile, or Goldman Sachs. So quite big companies. And the telecommunication environment, or the requirements set for this language were rather I would say high and complicated, because for this domain, the hardware has to, and software obviously as well, has to deal with a lot of concurrent connections. It has to be really reliable. It works on a hardware that is not easily accessible, and usually it has to work well, I would say. Even if you update any software, it has to work reliable. So the environment and the requirements are rather not easy to fulfill. So also the language has to be very reliable to actually fulfill all of these requirements set for this domain. So the Ericsson actually they created in 1998 kind of a switch, which is the telecommunication device. Well, these days we would say that it's rather a complicated server, basically, because this is a hardware plus 1 million of Erlang, 1 million lines of Erlang code. And this device was running in production. That means it was handling quite huge telecommunication traffic. Obviously, upgrades were done. So all of the usual things that are done with the production hardware and software. And I would like to ask you, and I will answer that question at the end. Yeah, just think for a moment. After 20 years of running in production, what do you think? What is the downtime of this software and hardware, obviously? So this environment. What is the reliability? And yeah, just try to guess. I will answer at the end, because this is a very good proof that Erlang is really reliable and can work in production very well. But the example that actually you might be more familiar with that also works on Erlang is WhatsApp, the messaging application that was, the application was bought by Facebook in 2014. By, I think it was like $19 billion of dollars. But what is important for us is that at that time, only 50 engineers were working on maintenance and development of the application that had 900 millions of users. This is incredibly low number that also gives us a very good proof that applications written in Erlang are really reliable. But what is the problem with Erlang? Well, basically, it's the syntax, I would say. So it's very specific. It's inspired by Prolog, so probably not something that we, as let's say, users of modern programming languages get used to. That's the big problem, and usually it takes some time to get used to that syntax. And that's why that was one of the reasons why actually Erlang, I would say, evolved in time, right? And now we are talking about Elixir as a new language created by Jose Valim near, let's say, year 2011, 2012. Jose Valim at the time was a core team member of Ruby on Rails, quite famous web framework, and he was responsible for the feature called thread safe. So the feature is about running by the web server the same, let's say, a piece of code and running it in a safe from the thread perspective. So Ruby is maybe not the best language to do it, and it's rather unfamous because of that. So that's why Jose started to looking how the problem is solved in other languages, and he found Erlang, and after some time he said that actually he loved what he found there, but he didn't love what he didn't find there. And what he meant by that, so basically he loved the reliability, the tools, and all of the features coming from the Beam, from the Erlang virtual machine, but he kind of didn't like the syntax or the environment itself. So he decided to create a new language inspired by Ruby, and Ruby actually one of the main thing that influenced Ruby, or was one of the main reasons to create Ruby, was to give pleasure to programmers, so to make programming actually fun. So that was something that he liked in Ruby, and he tried to do the same with that new language that he started working on. So that's why Elixir is more readable. It's easier, I would say, to to understand that Erlang, but still works on a Erlang virtual machine. So the code that I've showed you in a minute, written in Erlang, in Elixir would look like that. So to somebody familiar with, I don't know, modern languages like Python or Ruby or something like that, that will be much easier to understand. So these days we actually live in a world where it's almost not possible to continue like making CPUs, transistors smaller to increase the frequency of the CPU. So what we started to do is we started to add more cores to our CPUs, but not all of the modern languages that we use can easily utilize all of the cores, or not all of them make that easier for the programmers. With Elixir and Erlang, we have it kind of out of the box, so we don't have to think how actually the cores are utilized by our program. It's very easily done by the Elixir or Erlang itself. More than that, we don't have to think, or this is kind of transparent to us as a programmers, if the other process that we are trying to communicate with actually runs on a different core, on a different node, or maybe on the same. It's really transparent and really easy for the programmer, for the developer to actually do it. And this is something totally different than how it works with other languages. When you ask, like, let's say, average developer, what is the toughest part of programming, most probably he or she will say that it's working with multi-threads, or doing concurrent programming, or something like that. Mainly because well, first of all, in these languages we have very weird constructions, like semaphores, like locks, mutexes, and things like that, to handle writing code that can run in parallel, basically. So writing that code is complicated, because you have to think actually how to do it. Debugging that code is actually a nightmare. So these languages doesn't support actually the very important part that is now more and more important these days. So writing a code that can run in parallel in a safe way. And this is something, once again, that we have kind of out of the box with Elixir and Erlang. So in my opinion, there are like 5, let's say, features of Elixir, Erlang, and the whole ecosystem, which heavily impacts how reliable programs created in this environment are. And one of the features is definitely functional programming. Next feature is a lightweight processes running on virtual machine. There is a actors models, so basically multi-threading, the thing that I started discussing. There's a supervision tree, so that ability to heal the whole structure, and this is ability to well, replace, let's say, the code running on a virtual machine without stopping it. So hot code swap. And maybe let's start to discuss a couple of these features. Something that is well, maybe even the most important is using of a functional paradigm plus immutability. So in functional programming, especially when we talk about pure functions, we can compare it to the, let's say, I don't know, kind of a factory, kind of a line, production line, where we have these robots, and these are our functions, and the data representing by kind of a package that is transferred from one machine to another one. So we don't have a shared state. The data is passed to the, let's say, first the first machine. That machine operates on a data. So our pure function does some some algorithm, some changes to the data, and it passes the data, changed data, to the next machine, so to the next function. There is no side effects. We assume that there is no side effects here. What kind of benefits we have from it? So definitely, what we can parallelize things, right? Because these functions are kind of separate and should not impact themselves. The testing is easier. Debugging is easier, and we have something that is called memorization. So basically, we can replace, let's say, the whole function or the computation, knowing what is the input by the result of it, because we assume that the result of having the same input will always give the same output. So we have a lot of benefits. I would say that predictability and debugging is much easier. And immutability, this is to be honest, something that was totally new to me when I started coding in Elixir. Something that is initially, well, maybe something more or less like a question mark, actually, why? But when you understand this and you start to use that properly, then it's a great feature. So basically, when you allocate, what is immutability? When you allocate some, memory, some area in memory with some data, it stays like this. When you want to, I don't know, for example, add something to the list, actually that means that the list is copied plus the new element is added, but the original list stays there. Obviously, there is a lot of performance improvements around that to speed it up, but the general idea is like that. So as we see here, we have A that actually, let's say, indicates that initial list with 1 to 3. But then if we change that reference, the initial data allocated with 1 to 3 stays there, and only if the garbage collector is run or the process is killed, the memory is removed. And then in line 5, we see something that we can name, can call that factory, right? We have data A, then we pass it by the pipe operator to the first machine, which does something with the data, and it passes its result to the next machine. So the immutability and functional paradigm is one of the things that makes the programs written in Elixir and Erlang very reliable. But there is more. Obviously, we have very lightweight processes running on virtual machine. So basically, this is something different than a process or thread of the operating system. In other languages, like for example in Java, when we create I don't know, like for example, like thread, it allocates 1024 kilobytes of data. In Elixir, in Erlang, it's if I'm not mistaken, 2.5 kilobytes. So the difference is huge. And what it gives us that ability to spawn a lot of processes, a lot of let's say functions that can be run in parallel. Sorry, but the process that I'm talking about is not a OS process. It's a process that runs within the virtual machine. So it's presented here on that slide. We have Erlang virtual machine that runs as a one OS process, and within that process we have this small lightweight Erlang processes. So we as developers, we are not afraid of creating these lightweight processes. Actually, when you take a look on any running Elixir or Erlang program, you will see that there is really a lot actually of processes running at the same time, talking with each other. This is the usual structure of the program itself. And this is connected with how the multi-threading looks like, because it's based on actors model. Actor is, well, basically a function, basically the process running on a virtual machine. But these processes, these functions, communicate with themselves, sending some messages. So we have these actors represented here by circles, and each of the function has its own mailbox. If we want to communicate with that process, with that function, we send a message. That message is added to the mailbox, not processed immediately. Sorry. So we don't have that immediate response, and then each of the function goes through the mail through the mailbox and process each of the letter, each of the message that is there one by one. So we don't have anything that is like a shared state or anything like that. Only, let's say, within one process, within one function, we can say that there is an internal state. There is no shared state. And as we know, shared state is a source of huge evil and problems with programs these days. Because if it's shared, then anybody can actually change it, and debugging once again is a nightmare. There is kind of let's say a lot of similarity with microservices here. So we have functions running in separate and talking to each other. So yeah, here we have some example of it, how it's done. So we have a module. That module mother has one function waiting for a message. Then you have receive, which actually goes through the mailbox, let's say, and it checks if there is any message matching that pattern with son and message, and if there is something, then actually it prints it out. And then from the current function, from the current process, we spawn another process with that mother and waiting for message function, and in the last line we send the message to that process, so it will be printed out. Another feature that actually impacts the reliability heavily, I would say, is that ability to heal, and it's done by the supervision tree. So basically, we have special, let's say, processes that are supervisors, here represented by the green circles. So the only responsibility of the supervisors is to check if everything is fine with their children. So with the processes that actually do something, right? Some process of data or anything like that. And that structure can be nested. So we can have other supervisors within that structure. And if the supervisor notice that something is wrong with his child, he can do something with it. He can respawn the process. He can replace all of the workers by their new instances. Do something with the fact that something went wrong. For example, some process crashed or anything like that. And we can easily basically decide what to do in this situation. So here we have app supervisor module that has 3 children, module 1, module 2, and module 3. And in the line number 9, we initiate that structure, and we indicate what kind of strategy it should work with. So the default one is 1-for-1, which means if you notice that the process is down, one of these processes is down, then just replace it by its new instance. But other strategies are possible. For example, remove all of the existing modules and replace it by its new instance. So let's imagine that we have a process responsible for connection to the database, right? It's very wise to have it under the supervision tree. So if somehow the process controlling connection to the database is down, then we can, for example, reconnect or do something with that fact. So it's very important, let's say, for the telecommunication world, where we cannot easily, first of all, access these devices or connect to them remotely or do anything like that. So by that feature, we ensure somehow that our program can heal itself. And the last feature from my list is ability to replace the code running on the virtual machine without stopping the existing program. So this is going back to the very first slide that I showed you. We don't want to shut down the server or the virtual machine, then replace the code base and run it again, because we have some gap, we have some pause. But we want to rather just replace the code, and we want to tell the virtual machine how to do that transition, how to switch from the old version of the code base to the new one. And it's done very easily. So here we have a bank account module. It has version 1.0.0, and let's say that with that very first version, we just represent bank account as a number, as how many dollars you have on your bank account. But after some time, we decided that maybe there are better ways to represent this bank account by, for example, a list of operations on a bank account. So we've prepared a version 2 of our bank account, and we have a very special function here, code change, that tells a virtual machine how to switch from version 1 to version 2. And we don't have to switch down the program, the virtual machine. It will immediately start working with a new version of the code, and it will know how to migrate, how to do the transition with the state, which is crucial thing here. So where we actually use Elixir these days, probably the most famous and popular thing is Phoenix framework, so web applications. But also something that is used heavily is Project Nerves, which is a very lightweight version of Erlang virtual machine running on embedded devices. And who uses it? Well, actually, I was surprised, but many quite big companies use it, like Spotify, WhatsApp, obviously, Pepsi, Discord, Square. There's even a company called Rose Point, and they they do this hardware for boats, like for navigation and stuff like that. So you can imagine that it has to work for months, basically, even sometimes without ability to do anything with it, like upgrade or connect to it remotely or anything like that. And they, after a couple of years of using it, they said that, well, they didn't see any actually virtual machine errors. They even don't have any errors connected with the language because they use Elixir. And what is most important for them is they observe very stable consumption utilization of resources. So basically, virtual machine starts, and for months it runs with the same level of resources. So to summarize, functional programming, processes on virtual machine, actors model, supervision tree, and hot code swap are these features of Erlang that makes programs written in that language very reliable. And now coming back to the question that I asked at the beginning, what is the downtime of that switch? So that's quite incredible, but there are 9 nines, so 0.6 seconds of downtime over 20 years. That's pretty amazing. All right, I think it's time for questions.
On the left side, there is a Q&A option. So if you can click it, this is the fourth one counting from the down. So if you can click it, then you should change to Q&A.
All right, I'm trying to find it. Sorry, I am totally new to that.
Yeah, that's it.
Exactly.
Okay. So if you have any question for Krzysztof, you can just write it down and it will show up at the center.
Guys, any questions? All right, how well does Elixir work with Docker? I would say that there is no special thing with Elixir and Docker. I use it personally. I use it for releases on Amazon to prepare a package that then is run on Amazon. So yeah, it works really nice. I mean, no difference comparing to other technologies, to other languages or anything like that. But if you have any, like problems, issues, or any observations with that, then I would like to hear that as well. All right, we have another question. I hear RabbitMQ recommends no more than 40% RAM usage due to issue related to immutability. What would such issues be? To be honest, this is the first time I hear it. I mean, from my experience, actually, the RAM consumption is quite low when it comes to that, but it really depends on what kind of programs you have. Because, for example, with, I don't know, games or anything like that, when you have a lot of changes of the state, immutability is actually something that decreases performance, because yeah, as I told you, when you change something, you actually create a copy of it. So there is a lot of operations with that. So I would say that actually it really depends on how many changes for state you do. What is your deployment system recommendations? For I think like 2 years or something like that, I use the internal Elixir releases mechanism, and it works really well. So I think these days there is no reason to check or use something else, because the internal mechanism is yeah, really reliable, at least from my experience. How reliable is live view? Well, definitely it is. I mean, I have contact with many companies running it in production, using things that you, well, somehow are done by SPA, front end applications before, and now it's done by the backend. So as with, as the same like with other technologies, there are some usages that are not maybe designed for that case, but in most cases I never heard that somebody had some problems with reliability of live view. I think it's a very major technology these days. What cloud servers do you recommend for deployment in Elixir Phoenix? Personally, I have experience with Amazon and Google Cloud, so I know that it works pretty well. I've been using Heroku as well, also no problems. I'm not sure about Microsoft Azure, so I am not able to tell you, but AWS and Google Cloud works pretty well. Is it hard to find customers interested in developing projects in Elixir? And this is a very hard question, actually. I would say that no, there is more and more startups, at least from the environment that I'm working with, like in, for example, US, Berlin, UK, that actually they even switch to Elixir. So the technology, in at least in my opinion, is more and more popular in Europe and US. How do you see Elixir coming into blockchain in near future? I don't have any opinion, and I don't have any knowledge about that. So I'll just skip that question. Sorry. What is your IDE? Yeah, so I use Visual Studio Code, but I also tried using Vim, just a pure Vim. It's okay, it's fine, but well, it's not developed with the same pace as Visual Studio Code these days. You mentioned AWS and GCP for deployment. Any preference between both? Actually, there is really no difference, because you deploy Docker image in most cases there. So um, it really doesn't matter. I would rather think about additional, let's say, services that you have here and there. I mean, in AWS and GCP that you can use, rather than the Elixir thing itself.
Let's say it's gonna be the last one, because I know that you're in a hurry also. So
Yeah, no problem. Can you share some plugins to Elixir on Vim? Oh my God! I mean, there is one, but to be honest, I don't remember the name. There's not that many. Not definitely not that many as you see in Visual Studio Code. So the choice is much lower. But actually, it depends. What do you need, right? If you just want to write code there, then you have highlighting or things like that, and that's probably enough. But if you want to, I don't know, debug it, run tests from it, or do any fancy things, then you won't find it in Vim these days.
Krzysztof, thank you very much.
Thank you.
Great presentation. I can see in comments that everyone likes it. So
Awesome.
so someone even expect you at the next meeting.
Thank you.
Thank you very much. Thank you very much,